Good morning to one and all. Today, we are going to see about the problem on a symmetrical fault. Take down this problem. A symmetrical fault occurs on a four bus system shown in the figure. Okay, occurs on a four bus system. Determine the fault current and the post fault voltage and the line current. As we seen in the previous formulation, we need to solve this problem. Say here in this problem, there are two generators are there and four buses are there. In that, after first bus, transformer one is there. After that, again, two lines are there, two transmission lines like a overhead transmission line. Maybe say, for example, this generator is 100 MVA, 20 kilovolt and having the impedance of 15% and having a transformer that the rating is not given. But the leakage reactance is given. Leakage reactance is given as 9%. And as well as here, two transmission lines are given. There also, that leakage reactance is given as 10%. After that, bus 3 is there. After that, again, one transformer is there that is connected to the fourth bus that is being connected to a generator 2. This second generator also having the same ratings like 100 MVA, 20 kilovolt and having the reactance of 15%. So what is the first step? First step is to draw the reactance diagram. So reactance diagram we need to draw already given in the problem like generator 1 reactance is 15%. So here as I said generator we are converting into per unit. So 1 at the angle of 0. 1 at the angle of 0. Okay. The base values and actual values are same. So the answer will come at 1 at the angle of 0. So here positive and negative terminal that also we are taking and here yeah. So sequence positive and negative sequence that we are taking, and here the leakage reactance of a generator is J into 0.15 and the transformer 1 J into 0.09. So that leakage reactance we are taking for the transformer. After that, two lines are there, line 1 and line 2, having the leakage reactance of 10%, that is J into 0.1. And here is J into 0.1. How this 10 becomes 0.1 means it is in percentage divided by 100. So you'll get 0.1 J. And here the transformer leakage reactance again it is given as for all the transformers. The leakage reactance is given as J into 0.09. And it is connected to one bus and again having the generator 2 having the leakage reactance as 0.15. And here also you will be generator voltage, you will be having 1 at the angle of 0. So this is the positive and negative sequence of this reactance diagram. The first step is to draw this reactance diagram. What is the second step? Second step form Z bus using bus building algorithm. So formation of Z bus using bus building algorithm. So what is the procedure? The voltage source means you need to short circuit. That is the procedure. Already we have seen how to frame the bus building algorithm. So if not, I will give that that class and a few problems that also in the description. So that also you can watch and come back. So here voltage source are short circuited. So here it is J into 0.15 that is there and it is connected to the one bus. These two lines are there in parallel that we have converted into one like a parallel means. So here J into 0.1, J into 0.1, same values means divided by 2. That's all. So if it is in parallel, so J into 0.05. So here it is J into 0.09. So 1, 2, 3, and 4 buses are there, and here J into 0.5. What is the first step in the bus building algorithm? So you need to choose a reference bus, and you need to choose a new bus. So new bus is 1 now, and the reactance is J into 0.15. Sorry, impedance. So impedance is equal to R plus JX. So R plus JX. So R is absent here. R is not given here. So directly you can take the reactance as impedance. So R plus JX. So 0 plus J into 0.15. Directly we are taking J into 0.15. So J into 0.15, one element is connected to new bus. So only one element. So 1 cross 1 matrix will come. Z bus is equal to J into 0.15. So this is the first step. So next, from here again, this is now you have to consider this 2 as a new bus, and 0.09 is the element that is connected. So this is a new bus. Now 2 is the new bus. Okay. So here the same value, whatever the same value that you are writing here. And as I said, in the previous class, T rule. So whatever the values coming over here, the same thing you need to copy paste. So how to do this? So here, whatever the answer is coming, the same thing you need to write over this. And what is this value? This J into 0.24 is nothing but here 0.15 plus 0.09. That is 0.09 plus 0.15. So if you add this, J into 0.24 will be coming. Okay. So next, next is what? Again, we need to check the next new bus. New bus is 3 here. In the problem, new bus is 3. How it is given? Yeah, 3 bus, third bus. So J into 0.05. So J into 0.05. So how to do the same 2 by 2 cross 2 matrix now? Whatever is there that you need to copy paste here. And here, what you need to do is whatever the answer coming over here. Yeah. So whatever the first, whatever the answer coming over here, the same thing you need to copy paste here, and here also 2 cross 2 matrix. So here whatever the answer coming over here, that you need to copy paste, and here also whatever the answer coming, you need to copy paste here also. This is the some T rule you need to follow. What is this value? This value is nothing but this value, that is J into 0.24 plus J into 0.05. So that comes the J into 0.29. So this is the Z bus matrix. Now again, fourth bus, that is a new element, that is J into 0.09 is connected. So what you need to do, whatever the 3 cross 3 matrix, the same thing you need to copy paste. First of all, the same thing you need to copy paste. So here, you see the same thing, the same matrix. What you need to do is you need to copy paste here. Same matrix you need to copy paste. First of all, same matrix you need to copy paste. Next step here, the same thing, whatever the values coming over here, the same thing you need to write here. And here, this matrix is nothing but this matrix is nothing but this transpose you need to do. So whatever the answer coming over in this column matrix, make transpose the same thing you need to write here. Okay, so this you need to write here. So how this comes now? This 0.38 comes now. Whatever the value coming over here, that is J into 0.29 plus new element J into 0.29, J into 0.29 plus J into 0.09, J into 0.09. So that you need to multiply, sorry, that you need to add. And you here you get the answer as J into 0.38. So easily you can write over here, that is J into 0.38. Next, how many buses are there? Again, one more bus is also there. That is J into 0.15. That is the new element. That is the new element. So what do you need to do? The same matrix, 4 cross 4 matrix, whatever we got, that matrix you need to copy paste. So here you need to 4 cross 4 matrix, just you need to copy paste the 4 cross 4 matrix. So here whatever the answer is there, that you need to just copy paste and write over here. So this matrix, this column matrix, whatever comes, the trans you need to write over here, and whatever the answer we written. So how this 0.53 comes? How this 0.53 comes? 0.38. That is 0.38 j into 0.38 plus 0.15. Take your scientific calculator and calculate it, and you get the answer as j into 0.53. Now, what you need to do is you need to um, uh, eliminate the node 5 by using the Cron's reduction method. Here we are not going to use the Cron's reduction method, as I already said. Why we are not going to use the Cron's reduction method is the time taken for solving the problem will be more. So else some shortcut method already I have taught. Already in the previous problem I have taught. So that also I will give you in the description. You can watch later. So how to get how to do this shortcut method. So again, I'm explaining you just this matrix 4 cross 4 matrix you need to take out. Okay, minus okay 1 divided by this value, that is j into j 0.53, j into 0.53, j into 0.53, and into this column matrix, to this column matrix. That is the same thing you need to copy paste. Column matrix j into 0.15, 0.24, j into 0.29, j into 0.38. That you need to copy paste into this row matrix. This row matrix. Just you need to write it over here. So just to simplify it, this into this, you multiply and divided by 1 divided by j into 0.53, and this matrix you need to minus. So if you minus this, you will get the answer as this, that is j into 0.1575 up to j into j into 1.075, like that you will get the answer. So in the comment you just tell me whether you also get the same answer or not. That you need to please you need to comment. Whoever watching this video, you need to just comment whether you are getting the same value. I think 100% sure you will get the same answer, same matrix. That is Zij news equal to the same matrix you get by using the our shortcut method. Next, step number 3. Step number 3, we need to calculate the fault current. Fault current IF is equal to V naught divided by ZQQ plus ZF. So V naught initial value 1 at the angle of 0 degree divided by ZQQ. So here what you need to do is you need to calculate this fault current. ZQQ is nothing but impedance at the qth bus. Say for example, this is the qth bus. That is the fault is occurring on the 4. How it is 4? It is given in the problem. We are not considered. See, the symmetrical fault occurs on the bus 4. So symmetrical fault occurs on the bus 4 is this the qth bus. Now, what we need to do is here you need to just this all are connected in the series. This all elements connected in the series. Like j into 0.15, j into 0.09, j into 0.05, j into 0.09, all connected in the series. Okay, this all connected in the series. This alone Okay, this alone is connected in the parallel. Which one? This alone is connected in the parallel. So here what we are doing is we are just adding all these things. So if we are adding, I think you will get the answer as take your scientific calculator and you can add all these things. You'll get the answer as j into 0.38. That is the answer. That is all connected in series. No, that is the answer. That is what you got is j into 0.38. That is the answer you got. So here this is parallel. That is j into 0.38 is parallel with j, because this is the fault bus. This is the fault bus occurring. This is parallel with j into 0.15. So how to calculate, you know. So this into this, that is j into 0.38. Take your scientific calculator, j into 0.38 into j into 0.15. The whole divided by j into 0.38 plus 0.38 plus j into 0.15. Just calculate it. You'll get the answer as j into 0.1075. Is it here? Is it QQ? We are not considering because um, uh, all are say for example that is the fault at the qth bus. Okay, fault sorry, impedance at the all the qth bus. So here if you calculate you'll get the answer as j into 0.1075. Okay. So you just tell in the comment you got the same answer or not. So here what you need to do is 1 at the angle of 0 degree divided by j into 0.1075. Take your scientific calculator and just convert that into polar form. Polar form 1 divided by j into 0.105 and convert into polar form. You'll get the answer as 9.3 at the angle of 9 minus 90 degree per unit. That all in the per unit. So this is how we need to calculate the fault current. So what is the actual current? Actual current in kilo amperes in the sense actual current is per unit value in the base current. Per unit value already we calculate 9.3 the angle of minus 90 degree into base current. How to calculate base current? MVA divided by root 3 into kilovolt. That is the formula. So what is the MVA given? MVA given in the problem is 100 MVA. Generator is 100 MVA. So 100 MVA divided by root 3 into this kilovolt. So kilovolt is 20. How it is 20 means? Yeah. So here it is given as 20 kilovolt. 20 kilovolt at the generator 1 and generator 2. Here see the fourth bus we are calculating. So we have to take as and 20 kilovolt. 20 kilovolt we have taken. And so further simplifying, you will get the actual current in kilo amperes as 26.85 kilo amperes. That is the actual current in kilo amperes. This is the step number 3. What is the step number 4? Step number 4, we have to calculate the post-fault voltages. Post-fault voltages we need to calculate. That is, this is the formula already we derived. V1F is equal to V0 into V0 minus Z Ij, that is 1, 4, because Ij means from the first bus to fourth bus, post fault. Okay, first bus to fourth bus. So I is for 1 and J is 4. So Ij into If. So here V0 is 1 at the angle of 0 degree minus Z14. Z14 you need to calculate from this matrix. Z14 is, yeah, J into 0.424. So here J into 0.424 into fault current. Fault current already we have calculated as 9.3 at the angle of minus 90 degree. Just you need to substitute and you'll get the answer as 0.6056 per unit. That is V1F. Similarly, V2F is equal to V0 minus Z24 into IF. Just substitute it. You'll get the answer as 0.3686 per unit. Similarly, V3F. V3F 1 at the angle of 0 degree minus this Z34 from that matrix. You just take and write, and here IF. IF is 9.3 at the angle of minus 90 degree. You'll get the answer as 0.2374 per unit. Similarly, V4F. V4F also just substitute it and you get the answer as 0 per unit. What is the step number 5? Post-fault line currents. Post-fault line currents, that is IIJF. That is, this is also we derived IIJF is equal to VIF minus VJF divided by ZIJ series. Post-fault. This is the post-fault voltages. This is the post-fault line current. Okay, this is the formula. Just substitute it post-fault I12F. I12F is equal to V1F minus V2F divided by Z1. So V1F what? Already we calculated V1F here. So V1F 0.6056 minus V2F 0.3686 divided by Z12. Z12 you need to take it from that matrix. You need to take it from this matrix, that is 0.172J. Just you need to substitute here. Z12 is 0.09. You need to take it, take this from the impedance diagram. So 0.J into 0.09. Okay, always remember you need to take that from the ZIJ series. Already given clearly ZIJ series. This is not from the matrix. It is ZIJ series. So you need to take from the impedance diagram, that is J into 0.09. Further simplification, you will get the answer as 2.634. Next, then next 1, 2 we got 2, 3. 2, 3, the same formula. V2F minus V3F divided by Z23. Just Z23, what is the this V2F, V3F? You can take it from here. V2F, yeah, V2F, V3F. Next Z23. Z23 is from this reactance diagram. Z23, that is J into 0.05. Just substitute here J into 0.05. Yeah, you'll get the answer as 2.63 per unit. Similarly, I34F. I34F is equal to V3F minus V4F divided by Z34. Just V3F value. Yeah, already you know. V4F 0 per unit. That also you know. Divided by Z34. Z34 from the reactance diagram, it is J into 0.09. Further simplification, you will get the answer as 2.637. So these are the currents for the post-fault line current. So post-fault line currents, that is Z. So Z12F, Z23F, Z34F. So next post-fault line voltage also we calculated. That also asked in the problem. Next fault current. Fault current also asked in the problem. So after writing this, after calculating this, you need to highlight the answer at last. So whatever asked, say for example, determine the fault current. Fault current IF you need to write. Post fault voltages you need to write all V1F, V2F, V3F, V4F. Line current, post fault line current. That also you need to write. I12, next I23, next I34. That and all you need to highlight and write in the at the last. So sometimes they will ask only fault current in the 5 marks up to fault current they may ask. So that time you can stop up to here. Sometimes they may ask post-fault voltage and post-fault line current also they may ask that. There you need to calculate. So this is the 10-mark question. So a 10-mark question. So in that you need to formulate this matrix also by using the Z-bus algorithm. Z-bus bus building algorithm. So always follow Z-bus bus building algorithm. Why? Because already in the predefined algorithm, already it is given. That class also I will give in the description. You can watch that like a symmetrical fault analysis. So that also I will give in the description. There some steps are there. The same steps we follow. First, draw the reactance diagram, formulate the Z bus. Next, calculate the fault current. After that, calculate the fault current. After that, you need to calculate the post fault voltage and post fault line currents.